I had a feeling that because I know the numbers that they should be like this.
Yeah.
And the numbers also tells you that you are fairly correct, because notice that you have much less going from 4 into 3, that value, compared to 3 going into 4.
Yeah.
And that is because the peak always are very steep, and then they are a tail.
Okay.
So you have a lot that are going into the neighboring channel. That's the high percentage.
Yeah.
But this one is steep, so only a little bit goes into the first peak.
Okay.
That one. So you can actually tell the shape of the peaks as well if you know what you're doing.
So the tail on the right is much bigger, always?
Yes,
okay.
It is. So it's always low, high, low, high, low, high in numbers. So like 1, 15, 1, 15, 1, 15.
Okay.
More or less.
Yeah.
And for me, I of course always look, also when I have student trainings, they're way off. It's not gonna work.
Yeah, you don't even have to.
Just let them play around a little bit and then sit and explain to them.
Yeah.
But
that comes with experience as well. Yeah.
But the smart student realize, it tells me something about how the curves are situated.
That's right.
So they can use it as an internal control. So obviously, the more button that we release them on, the more they have to think.
Yes.
Because choice of axis, up and down, you have a ton of permutation if you just close your eyes and start.
Absolutely.
Yeah. I was just thinking, now that we were talking here, when you do a simulation, you are generating numbers.
Yeah.
I need a piece of paper. we need a piece of paper. I have a broad. Yeah. It was just to see if I could work out. The way this machine is operating is that it has 1,024 channels on each axis.
Yeah.
And it doesn't matter whether it displays it logarithmic or linear, it's still 1,024 boxes. Bottom line is, for a cell to lie up here, it must have some kind of number. Yes?
That's right.
And a much lower number when they're lying in here. So in fact, each dot have 4 numbers, because it has a number for each of their channels. 1, 2, 3, 4. And let's just for fun play that this is 3 and this is 4.
Yeah.
Okay. So for FL1 it will be close to 0. And it will be close to 0. And now we are taking this one dot.
Yeah.
So it will be, say, 725. And it's not 0, so like this.
All right.
Because now it has moved out on the FL3 axis, right? And the next dot that are lying here, that will be 10, 10, 10, and 725.
Yeah.
You see the concept?
Yeah.
Yeah. And of course you also have a value for the forward and the side scatter. That's the 6 values that you actually get out of it.
Yeah.
Okay. So when we increase the sensitivity, that is the same as to increase this number.
Yes.
So question is if we could just make the equation that every time you move this one up, you add a little bit to this value.
Yeah. Yeah.
And then this value is run through the compensation matrix.
Yeah. So it gets readjusted.
So
50% off minus 15%.
Exactly.
Like this. Yeah.
Exactly. Because then if you move the voltage up, this number goes up.
Yeah.
But then you also have to change the compensation afterwards to make it fit on the axis.
Yes. I think that's the way to go, actually. Henrik and I have been playing a bit on Excel.
And when you start playing with these where the compensation is just set to 0. Because no, they can't be 0. No, they are 0.
Yeah, because it's minus 0.
Yeah, they're 0.
Yeah.
They're 0 because then when you start playing around, they will be lying up here. and in here
Yeah.
instead of where they supposedly should be. So as long as the compensations are 0, you will still display the right number.
That's right.
It will just be, say, 725, and this one is then 50 or so,
Yeah.
because it's moved up a little bit.
That's right.
And once you play with the compensation, the matrix there, that one will be adjusted to 10, that one will barely be affected,
That's right.
and then you get the true values
Yeah.
that are shown.
Yeah.
That's probably the way to do it.
And I think it's an important point that said barely be affected. It could be a little bit affected. So we have a little factor on this,
It will.
isn't it?
It
Yeah.
will be affected
Yeah.
a little bit, yeah. It will.
Okay. The equations are not difficult, and to adjust these numbers are not difficult
No.
either, because it's simple math. It's
simple
minus
math.
50%
It-
or minus 1%.
Exactly.
Yeah.
But it's just that the software you are building take into consideration that they have to play around with it.
Yes.
So whatever
Absolutely.
number they, for that matter, it doesn't have to be a sliding bar. It could just be a number that they punch in.
That's
Say,
right.
I
Yeah.
want 1.4 or 1.5,
Yeah.
and then see the result,
That's right.
right?
Yeah.
And it's just, if we can get these two to interconnect
Mm-hmm.
and reflect what is going on, for one thing, the student will learn more.
Yeah.
Because they will see the relationship. The other thing is, now I have set this one, and also the other one, and said to you, I have set the compensation, I have lined up the instrument correctly.
Yeah.
Yeah. If we then close down the system and start all over, I could do it again. But chance is that I hit exactly the same number and exactly the same number. Slim to nothing.
That's right.
But that doesn't say that the second try
Is wrong.
is
or-
wrong
no.
compared to the first one.
No.
It's very objective what we're doing here.
Mm-hmm.
And this is why it's important that 5 students that are sitting next to each other and start comparing notes, they can actually see they get 5 different settings,
Yeah.
yet it is working for them.
Yeah. But those 5 settings wouldn't be completely different.
No,
They're close by, right?
Yeah. It will be within 10, 15 in voltage, and
Yeah, and
here 0.123 or so,
Yeah.
and here perhaps 1 or 2.
yeah, because there is a
There will be a limit where it's so way off that they can see this
Yeah.
is not working. But small, subtle differences, they barely can see it over here, but it will reflect in the numbers.
that's right. And there is a little bit of random.
Yes, there is. And that
Okay.
just reflects every user that comes down here. I mean, I can ask my technicians to set it up, the 3 of us, and we won't hit the same number.
No.
And we can't agree on one being more right than the other. Because it's a matter, as you said, oh, you have the sensation for...
Exactly.
Yeah.
Exactly.
And I have been sitting looking at this over and over again, so I believe this is the right one.
Yeah, it's very visual as well. When you look
It
at
is.
this, how much you want to cut off down here, and
Exactly.
you know, so
Exactly. And
Yeah.
that is almost religion. You know,
that's right. Yeah, you,
of how people
and
are
you
doing it.
swear by your
I swear by my
calibration.
system,
Yeah,
yes,
yeah,
and
yeah,
they
absolutely.
have minute differences, and it doesn't make any difference for our experiment.
No.
We can't necessarily compare our experiment completely, because the differences could be big enough, so I would score population 1%, the neighbor would score it 1.5,
Okay.
right? So if I do a long-term experiment, it would be me that was running all the samples, not random people every time.
That's right. Yeah. There must
And-
be some consistency.
Yes,
Yeah.
and the machine can remember every data file that I record. It can remember all the settings. So if I come in a week, I can say to the instrument, line up exactly as you were a week ago,
Okay.
and then I can carry on.
That's very cool.
So that consistency is still there. It's not completely random what we get out
No.
of the instrument, but I think it could be important for the students that they, when you discuss it with them afterwards and say, okay, what number did you get?
Yeah.
Put them on the board.
We
What
could
number-
even save this, right?
Yes,
The student
yes.
could save the setup.
And what number did you get? Different and what you
Yeah.
got, and you all solved the case because it went through and the computer said okay for your sample.
Yeah.
So obviously there are more than one solution to the question here.
That's right.
Yeah.
And that's important for them as well to have.
I think it
I
is.
have to develop a feeling. I don't have a number that I take from my pocket.
No,
and,
exactly.
you know.
There's not a solution where all the numbers is just sitting in your protocol and your salt. You got to know what you're doing.
Yeah.
Because else it's the black box that's controlling you.
Yeah, then you wouldn't have the need for detection and calibration.
No,
and
no,
so
no,
on,
no. Then
and
I
that
could just
machine.
punch in
Yeah.
the numbers and
Yeah.
carry on. Yeah.
That's right. Fantastic. Now, I still think that's within the scope. We can
Okay.
do it. We
Okay.
can do it.
But I think this was the best way to illustrate
That
for you
was
what.
very nice. No, I become so, because I've seen your lectures and so on,
Mm.
but it's different.
Yeah,
sitting here.
no, exactly.
And that's the point with the simulation, because it's very different than passively watching all the 7
Absolutely.
hours of.
Absolutely.
You get a lot of the theory, but when you come here, so how do I use this
Yes,
theory?
yes.
So the simulation is the dot, the final dot.
Exactly.
in it.
And now that we give both the lectures and then we have a video on this software and this software even before they come here,
That's right.
and then they have to sit down and actually try a generic software and what have I learned so far?
That's right. How was the 7 hours
Yes,
of lecture?
exactly. And yeah,
By the
if you
time
don't
they
get that,
reach-
go back.
That's right. And by the time they reach here, they consider the
They-
screen is different, the software is different, but they know
But
the concepts.
There should be a lot of the concepts saying,
Yeah.
oh yeah, we have solved that, and I know that these buttons are the compensation and why they're there. It's not just for entertainment
No.
or irritating us.
No. It's beautiful. All right.
All right,
Fantastic. Thanks.
no problem.
I'll get on with the simulation, talk to Henrik, talk to the designers and so on. Have the opportunity to talk to your the guys with the money.
Well, he mailed the